Our lesson for today will be looking at Physics 1505. We are still busy with Newton's second law of motion. In this lesson video, we'll be looking at these types of diagrams, which is the tension system or the pulley system in higher dimension, meaning that we'll be looking at much complicated systems compared to the ones that we've been going through so far. So let us start. So today we'll be not solving any questions. We're just going to be generating equations for this particular types of questions. Remember that we're busy with examination preparation now, and then the challenge now is when we have a system that has three masses or three objects connected by strings or ropes. So far we know how to solve a system that consists of two objects. We know how to generate equations. We know how to solve the acceleration of the system. We know how to solve the mass of one of the objects. We know how to calculate the tension. We know how to calculate the coefficient. Basically, we can answer any question. So the problem is when we have this type of systems. So in this lesson video, we are just going to be looking at guidelines on how to solve this, and then you should be able to solve any question based on a system that has three objects. So suppose we want to answer any question based on this type of a question, and then remember that the first thing that we have to do now is to draw a free body diagram for each. So we have this system that is connected by strings, and then on object 3 there's a force applied this direction, and it causes the system to move to the right. So remember that in this case you're going to take right as positive, and then you're going to take the opposite direction as negative. And then there is kinetic friction. This simply indicates that there is kinetic friction. Now from here, the first thing that we have to do now, let us draw free body diagrams. So for the first one, we have normal force Fg and force applied, and then we have our tension and kinetic friction. Now before we do anything, let us label our tensions or our strings. So the tension between 2 and 3, we are going to say it's T1, and then between 1 and 2 it's T2. So the tension that is experienced by object 3 is T1. So we go ahead and draw a free body diagram for our next object, which is 2. So we have normal force Fg. The object T, actually 2, it moves to the right due to T1. Remember that it doesn't experience any force applied to object 2. Then we have T2, this direction, and we have kinetic friction. Then the free body diagram of our last object is normal force Fg, and then it's moving to the right due to T2, and then we only have kinetic friction since there's no rope or string behind object 1. So these are the free body diagrams for our objects here. Now when it comes to generating equations, remember that we said since the displacement is to the right for all of these objects, then it means that we are going to consider all the forces which does work on the object, or we can say which are parallel to the displacement of the object. So the first one, or first equation, or let me say the equation of our first object, we look at force applied will be positive since it's moving to the right. We have force applied, then tension T1 will be negative, and then kinetic friction will also be negative, equals to ma. So basically this is the equation for our object 3. So for object 2 we have T1, which will be positive since it's to the right, minus T2 minus Fk, it's equals to Ma. And then looking at the next one, which is 1, we have T2 minus Fk, it's equals to Ma. So these are the expansions of our equation for each and every object we have here. Now we should understand something. If it happens that the question says calculate T2, T1 and the acceleration, or any question based on this particular question, a scenario, you can see that there is a link between object 1 and object 2. So where we see T2 in object 2, where we see T2, we can substitute by the subject of the formula of this equation. So you can transpose this to the other side. Then we are going to have T2 is equals to Ma plus Fk. So where we see T2, we can substitute by this. Then our new equation will be T1 minus Ma, remember inside the bracket, plus Fk. Then we have minus Fk is equals to Ma. So you can see this, and then if we can make this the subject of the formula, then where we see T1 in equation, this equation, where we see T1, which is this, we can substitute by the subject of the formula of T1. So that is how we basically solve these questions. On the next lesson video, we'll be looking at examples on how to solve this using values. Our second scenario, it's a bit different from the first one, but the only difference is this force applied. So for object 3 and 2, our equations will still be the same as our previous example, but the difference will be when it comes to object 1. So looking at free body diagram of object 1, we have something like this, which is our force applied, and then we have T1 and kinetic friction. So in this case, we can see that by the way the object is moving this direction, so the displacement of the object is this direction. Now we're definitely sure that T1 and Fk will be part of our equation because they do work. Now looking at this one, remember that all the objects which are perpendicular to the displacement, which form 90 degrees with the displacement, they will not do work to the object. That is why we don't include them when we use this equation. They will basically cancel each other out. So in this case, this force, it's not parallel to the displacement and it's not perpendicular to the displacement. So what do we do from here? Now we know that this force, it has components. The first component is Fx, then the second component will be Fy. There is a lesson video whereby you talk about components and how to determine the direction, their magnitude. Now in this case, we have to look at the component of this force and check which one does work to the object. So we can see that this one is perpendicular to the displacement, so it doesn't do any work. And then this one is parallel to the displacement, then we can say it does work to the object. And then the direction of Fx, it's in the same direction as the displacement, so it will be positive. So in this case, our equation will be fx minus t1 minus fk is equals to ma. Now, further expansion of fx, you should know that fx on a flat surface is F, which is the force applied cos theta. So this angle is the angle between the horizontal and that particular force applied. This F is the magnitude of our force. And then we'll be able to find its component, which is Fx. And then this Fx, the answer that we get here, is the one that will take part in the equation. Or we can expand this where we see Fx, we put F cos theta equals to actually minus T1 minus Fk is equals to ma. So that will be the difference between this scenario and the previous one. Let us look at this situation whereby we have two blocks which are in the air, and then we have one block which is on top of a table. So we can label this as T1, this as T2. The equations, remember that, let us start with the free body diagram. It's very important. For free body diagram, for 1, it will be, oh, by the way, there is kinetic friction here. Now, if the system is not moving, you should know that the questions will be very much simple, because from this equation, actually the calculations will be very simple. From this equation, remember that for all these objects, we are going to start with this equation to generate our equations. You should know that if the system is not moving, it is stationary, it means that we are going to have 0 here. And then meaning that F net will be equals to 0. And then we can just solve for anything that is required from us, looking at all the forces which does work to the object. So in this case, let us look at a situation whereby the system is moving, it's not stationary. So somehow the system is moving in this direction. Now we look at our displacement for 1. Displacement for 1, it will go up. And then the displacement for 3, it will go down. This means that if the system, the displacement of 2, it goes to the right, it means that we take right as positive and then left as negative. And then in this case, since the movement of 1 will pull or will affect the movement of 1, let me repeat, the movement of 2 will basically affect the movement of 1. Since it goes to the right, it means 1 will go up. So we take up as positive and then down as negative. Remember that we are dealing with vectors. It's very important that you take note of their signs. Now 3, since 2 is going to the right, 3 will go down. So we take down as positive for 3, then we take up as negative. So if you can check here, we are taking the direction of the system as positive. But in this case, we'll be looking at individual object. Where does it go? What is the direction? What is the displacement of the object? The direction of the displacement will be considered as positive. Then you can see here we have different directions. That is why we have to take note of each and every direction for these different objects. So as we have said, we are drawing the free body diagram of 1. Since it goes up will be T1 and then down will be T2, actually FG. Then looking at the free body diagram of 2, we have normal force, we have FG, we have it goes to the right due to T2, and then we have T1 this direction, and then we have FK. Then looking at free body diagram of 3, we have FG and our T2. So these are the equations that we have here. Now looking at the equations, since we have these free body diagrams, looking at equations for each and every object here, let us start with this one. We have Fnet is equals to MA. The displacement of this object is up, so you can see that both of these forces are doing work to the object, so we are going to include them, meaning that you are going to take, like we said, you are going to take up as positive, down as negative. So T1 will be positive minus FG will be negative MA. Then looking at the second one, the displacement of the object is to the right, so you can see that we have three forces which are doing work to the object. So it's Fnet is equals to MA, and then we have T2 which will be positive minus T1 negative minus FK negative equals to MA positive. Our acceleration is positive. Now looking at our next object, we can see that the displacement is down, so we take down as positive. In that case, we have positive FG minus T2 equals to MA. And you should take note that our FG it's always equals to mg. Then you should take note that our g is 9.8 unless stated otherwise. 9.8 meters per second squared. So looking at the relationships, we can see that if we make this the subject of the formula, we can substitute it here. Where we see T1, we can substitute by MA plus FG, and then where we see T2 here, we can basically substitute by the subject of the formula of T2, which will be FG minus MA. So where we see T2, we can substitute by this equation. And then looking at the overall equation after substituting, we have FG minus MA minus, where we see T1, we said we are going to substitute by this. So if we remove the brackets, we are going to have MA minus FG is equals to MA. Actually, I forgot that FK equals to MA. Now we should take note that this MA, not the same, is the mass of the objects, each and every object. And then we have this FG, which will also be different for each and every object. We have this kinetic friction, which is defined by FK, coefficient of K, G. So basically this is how we generate these equations. It's not difficult, it's very much simple. And we should also take note that we cannot use this and this to solve for anything, because you can see that the variables are different. So it's either we can start with this and this to find T1, because substituting T2 here, we are going to be left with T1 and find that T1. Then from the equation of T1, we can use this because you can see the relationship. So the two equations are connected by this one equation. Let's look at this scenario quickly. If you understood the first two scenarios, this will be simple for you, provided you understand the basics of this scenario. So looking at free body diagram, by the way, this will be T1, this will be T2. And then let's say the object is moving this direction, I mean the system, and then there is kinetic friction. Looking at free body diagram of 1, we are going to have something like this, which is T1, it's moving due to T1, then we have FK, we have FG. And then object 2 will move due to T2. We have normal force, we have T1, we have kinetic friction, we have FG. And then looking at 3, we have T2 and FG. So looking at, let us start with our first, actually let us start with 3. The displacement of object 3 is moving downwards, so we are going to take down as positive, up as negative, meaning that our equation here, we are going to have positive FG minus T2 equals to MA. Look at this one. Suppose this is T1, this is T2, then there's an angle here. Free body diagram of 1. The system, by the way, it's moving this direction. So it means for 1, it moves this direction. So free body diagram of 1, we have FG, we have kinetic friction, we have normal force, and then we have T1. Free body diagram, this one, free body diagram of 2, we have T2, we have T1, we have normal force, then we have FG. If this has kinetic friction, then we are going to have kinetic friction in this direction. And then for 3, we simply have these two forces, which is T2 and FG. It's simple to generate these equations. Now the equation of our first object, which is 1, we are just going to look at the displacement of the object and look at the forces which does work. So the displacement of the object is moving to the right, then we are going to take this direction as positive. So we are going to have T1 minus FK equals to MA. That's what we have. Looking at 2, we have, this is the displacement, by the way, so this direction will be positive. So we have T2, which will be positive, minus FK, which will be negative, minus T1, which will be negative. Remember that whenever we have an incline, we have that force, which is the FG parallel. But you should know that the FG parallel is this direction, so it will also be positive, plus FG parallel equals to MA. And then our last object, remember this is the free body diagram, it's going down, so we're simply going to have FG minus T2 equals to MA. Basically, you can see that this connects the two. We have another scenario which is like this. This is 1, this is 2. Or we can go ahead and try to complicate this situation further. Let us put another ones here. So it's 1, 2, 3, 4. So in this case, we have T1, T2, and T3. I just want to show you that once you understand the concept of these, it's very much simple to generate any equation for any situation. So the first object, which is 1, let us try to draw a free body diagram on top of this situation here. So we have T1, we have T2, we have normal force, and then we have FG here. Remember that if it is stationary, then we don't have any kinetic friction. For T2, actually for object 2, we have normal force, T2, T3, and FG. Then for this one, we have tension, and it's T3 and FG. Then for the last one, basically have T1 and FG here. So once you can identify the forces which are acting on the object and the forces which does work on the object, it's very simple to answer the questions. Now I believe this will clarify and assist you on how to generate equations for the examination preparation question that we have received. So after watching this lesson video, you can go ahead and look at the question and try to answer it. That's it for this lesson video. This is Paula SJ. Thank you very much.